Now let's talk about the difference between simple interest and compound interest. In this example, when we looked at how much interest we earned after 1 year, 2 years, 3 years, and 4 years, we were always finding the interest based on the principal, based on the money that was originally put in. When you're doing that, that's called simple interest. Compound interest takes into account the fact that you're always earning interest on the money that you have, okay? So compound interest is interest that is paid on the original principal and on any interest you have left in the account. And then the balance is the principal plus the interest that is earned, okay? So our compound interest formula is going to be, first off, let's put a definition of compound interest. Compound interest is interest paid on the principal plus interest already earned. So the formula that we use for compound interest is going to look like this. The balance, which is the amount you have left in the account, is going to be the principal times 1 plus the rate to the t power, which is going to be time once again. So we have here balance, and we have principal. It's all the same, most of the same numbers. We have the rate, which is going to be a percentage. Oops, I have to put a percentage. And then we have the time, which is in years, okay? So it's going to be a matter of finding the numbers that you need and then putting them into the formula. So let's look at the first problem that I want to do with you, okay? I'm going to write it out. And then we'll talk about it. All right, so you deposit $5,000 in an account that pays 3.7% compound interest. What is your balance after 9 years? So we have here our principal. It's paying this rate, and we are looking at a time of 9 years. So our formula is balance. We want to know the balance. That's what we don't know. Principal times 1 plus the rate to the t power, okay? All right, and the 3.75% is again going to have to be changed to a decimal, and so it's going to be 375 ten-thousandths. So let's go ahead and plug in our numbers. The principal's 5,000, so it's going to go there. 5,000 times 1 plus this number to the t power. Well, t is 9 because the time is 9. So now let's solve. We solve within the grouping symbols first. So 1 plus 375 ten-thousandths is 1. And I suggest that you write all these steps out so you don't get stuck. And so now we're with b, we're left with b equals 5,000 times this to the 9th power. So the next thing we do is exponents, so we're going to solve that. And if I leave that number on the calculator, then I can go second answer, and that says use my answer. and then I can do this button to the 9th power. So I'm going to take my previous answer that was on the calculator and do it to the 9th power. And so I end up with 1.3928, a lot more, times 5,000 is going to equal my balance. And leave that number on the calculator and multiply it times 5,000. Oops, I put 1 0 too many. And so my balance at the end of 9 years, this is quite a good interest rate. I will have $6,964.07. It's money, so we're always going to round to the hundredths place, to the pennies. And the 7, remember, is going to make the 6 round up. And so that is the balance on my account. Okay. Let's do one more together. We're going to have hold on. Brief pause for intermission. I'll move this up anyway since I'm on. Okay, so we're finding the balance of an account that you deposited $3,000 in with a 4.25% compound rate after 12 years. So we're going to find the balance. So let's always start by writing our formula. Balance equals principal times 1 plus the rate to the t power. The rate is 4.25%, so I need to change that to a decimal, 0.0425. And I'm going to go ahead and fill in my numbers. So the balance is going to equal, because here is my principal, here's my rate, and here's my time. Okay? All right, so 3,000 times 1 plus my rate converted to a decimal to the 12th power. So now I'm going to go ahead and add them together. 1 plus, and so I got that number, 3,000 times this to the 12th power. And again, I want to find the 12th power of this answer, so I'm going to do second answer, and then this button, and then 12. And so the balance equals 3,000 times this long decimal.
Cameron, please.
And then I'm going to multiply that. And so my balance is $4,943.49.